Thank you all for coming. How's your RSA been so far? All right. Yeah, big shout out and thank you, kudos to the RSA staff for making this experience so great. They do so many little things right that just go unnoticed. So big shout out and thank you. I'm here to tell you about the Secure Supply Chain Consumption Framework, or S2C2F. If you don't like that acronym, I mean, I kind of think it sounds like R2D2 a little bit. So, but yeah, if you don't like that acronym, just call it the Consumption Framework. This is all about how to securely consume open source packages into the developer's workflow. Things like NuGet, NPM, PyPy, Maven, Rust crates, on and on and on. Necessary disclaimer, this is for educational purposes. And a little bit about me. I lead the secure software supply chain at Microsoft. I'm responsible for securing the end-to-end software supply chain. As part of my work there, I helped lead and publish the Secure Supply Chain Consumption Framework guidebook that we then contributed to the OpenSSF. I've also been involved in SBOM, as SBOM is one portion of our overall strategy for securing our software supply chain. I've been an educator, and now I'm here to tell you more about S2C2F and how it can help your development team or your organization improve the security of how you consume open source. And now I'm going to tell you why it's so important. So Synopsys did a survey in 2021 that found that out of all survey respondents, that 98% of code bases contained open source. If you search across the internet, there are many other figures, different surveys that were conducted, but I think we can all agree that a large portion of all software today has open source in it. That becomes interesting when we think about the rise in attacks specifically targeting open source. So Sonatype's report, which they produce every single year, this last one that they produced showed that over 88,000 malicious packages were discovered in 2022. This represents a 742% average year-over-year increase in attacks specifically targeting open source. So if developers are consuming open source readily, it's for these reasons that this makes open source arguably the most important aspect of any software supply chain. And Microsoft is no exception. Microsoft loves open source. We have 83,000 unique open source packages used across all of our repos, used more than 11 million times at the scale of all of Microsoft's development. And this is what led us to focus on securing how we consume open source ever since 2019. So the journey so far, we've developed the S2C2F and began implementing it way back in 2019. We then wanted everybody to be able to benefit from these same practices. And so we published it in 2022, and then we contributed it to the OpenSSF, Open Source Security Foundation, which is a Linux foundation. It's a neutral place where industry peers can come together and work on solving the problems that affect all of us. And myself and another colleague, we lead and maintain this framework within the OpenSSF, and we have twice monthly meetings, and we would absolutely love to encourage any of you or any of your friends to come and join these meetings. We want to build this community. Our theme is Stronger Together, and that there's more truth in that than, that's an understatement. We want more people involved in this community helping improve. So throughout this talk, I'm actually wearing two hats. I'm wearing my Microsoft hat, and I'm wearing my OpenSSF hat as an OpenSSF member. And so the OpenSSF now has 2 security maturity frameworks. They have SALSA, which is very producer-focused, and SALSA just reached version 1.0, and they have requirements available for the build track, and they're going to be working on other tracks as well over time. Well, S2C2F is the consumer track. This is talking about how do you securely consume open source as a producer. And so these 2 maturity frameworks pair together. You should be doing them both. I'm going to show you a model in a little bit about how these things work together. So you can go to our repo on GitHub and be able to download the guidebook for free. It's at version 1.1 already. It's available in PDF and available in Markdown. The guidebook is complete with a high-level solution-agnostic set of practices, a detailed list of requirements for each practice, a list of real-world supply chain threats specific to OSS, and how our framework requirements mitigate them, a maturity model-based implementation guide with links to tools from across the industry, a process for assessing your organization's maturity, and a mapping of our framework requirements to 6 other supply chain specifications. So I highly encourage you to go to this repo, give it a star if you think it's awesome, and you can use this and bring it back to your team or your organization. Throughout this talk, I'm also going to walk you through the entire framework so that you have an understanding of the principles and the practices and the requirements. So what's really cool is that I've been working with the NSA Enduring Security Framework, and the S2C2F is going to be referenced in this guide that's about to be published. I had really wished they had published this before this talk, but you can go to this link where they have all of their other guidebooks, and this one on SBOMs and open source software practices will be there soon. It does reference the S2C2F, and it aligns with their guidance as well. So, I'm going to walk you through how we model this space. Here you can see that we've got the big blocks up on top: source integrity, build integrity, and release integrity. We've got the dependency horizontal that goes across, and we've got devices and identity on the bottom. So the top row is really the producer-focused stuff. The dependencies are really the consumer-focused stuff. And devices and identity is the access that you grant to this whole environment. Okay, so on the producer-focused side, that's where you could leverage SALSA. SALSA is going to help giving you requirements to help secure those areas across the top. On the consumer-focused side, that's where S2C2F comes in. And that's where I want to encourage everybody to come take a look at this and help secure this, because as I already mentioned, attackers are targeting open source and developers are just consuming it blindly. So for access and identity, this is like, think about your traditional DevOps infrastructure, your CI/CD platform. Think about all the identities that are being used and the permissions that are pervasive throughout your CI/CD infrastructure. You should be following zero trust principles for how to secure that. That's kind of going beyond the scope of this talk. I'm just kind of showing you the big picture and where S2C2F fits within the big picture. And if we think of that as one giant platform, you've got your whole DevOps platform. Doing all of these things are not enough, because you also need to make sure that your DevOps platform is configured securely, that you have security monitoring teams that are monitoring for anomalous alerts, or anomalous activity that is happening within your DevOps environment, because attackers are specifically targeting development environments now. You need to make sure that you have proper incident response scenarios prepared, and you should probably make sure you have business continuity and disaster recovery plans in place in case your software development infrastructure is affected in some way. So now let's dive into the S2C2F. So that was the big picture, and now we're zooming in. So the S2C2F has 8 practices or jobs to be done. And it starts with ingest in that kind of top right. And all of these 8 practices, they help describe the job that needs to be done and are ideal for CISOs or anyone interested in building their OSS supply chain strategy. These practices map to specific requirements, and the requirements are more targeted toward risk managers and engineering managers that need to go implement these things to secure their environment and secure how they consume open source. And these requirements that we're going to all walk through, these requirements were born from analyzing real-world threats and what sort of requirement we are suggesting people enact is what would mitigate against that real-world threat. So essentially, our list of requirements I'm going to take you through follows a threat-based risk reduction approach to securing your software supply chain. Now, we're going to end up walking through each one individually, each practice area, but just remember that these practices work in concert. It's not you just focus in one area. You need to make sure that you're ingesting things appropriately, that you're auditing that things are being ingested the correct way, and that you are enforcing that people are ingesting the correct way. And we're going to talk about that more in a second. But first, let me show you the real examples that we used to analyze and then make sure that we had requirements that were specific against these threats. So Salt Stack, this is a PyPI component that was affected in 2020, and it was exploited within 3 days of announcing a patch for a critical vulnerability. So we're going to talk more about how our update requirements can help mitigate and patch faster against attacks like that. ESLint was an incident where the package was maliciously uploaded, and so anybody that continued downloading the latest version of the package, which happened to be the malicious one, ended up downloading malware into their development environments. That gets into the project, it gets onto the developer machines, and it's a problem. And I think it's an industry-wide gap that we don't have malware analysis today analyzing open source prior to consumption. Typo squatting is a huge issue throughout open source. It's an older threat technique, but it still works. And because it still works, it's still being done. That's where there's like some sort of popular open source component, and so an attacker will upload a malicious component that almost looks identical to it in name, but there's like one character off. Like you might type something wrong when trying to download it and accidentally download the typo squatted version. CCleaner is when somebody, an advanced adversary had a presence on the build system, was able to compromise the software while it was being built and introduce their backdoor. And on and on and on. Left pad happened way back in 2016. We've actually started to see this type of incident again. Left pad is where the developer had a philosophical difference with the package ecosystem that he was a part of, and he chose to remove his code and his package from the internet. And because developers were pulling directly from the public internet to pull down that package, and it was no longer there, the internet broke. That's what the headline said. Left pad got removed and broke the internet. And so I'm going to talk to you about how you should be ingesting your packages in a little bit. UA parser.js at the bottom. This is where the attacker did not compromise the GitHub identity, but they compromised the NPM identity that they uploaded packages to NPM. So because they had compromised that identity, they uploaded a new malicious package, so it was the latest version, but it did not correlate back to the GitHub repo at all. And so that's why we need to be able to have provenance analysis connecting packages back to source. And NPM just recently announced that they are making that available so that packages now that get uploaded and published to NPM can have traceability back to source and back to its release. So these are the threats that we took to help us create our requirements. Believe me, there are a lot more threats, but a lot of those other threats basically just had the exact same mitigation. So this is kind of like the condensed list. And when we started building our requirements, we built them into a maturity model. So what do you think the rule of thumb was for open source governance for like the past decade? It was scan your open source for known vulnerabilities, inventory them, and then update them. That, in my opinion, is the bare minimum. I made that maturity level 1, because that's not good enough anymore. So each of these maturity levels have themes. So the theme for level 2 is focusing on vulnerabilities. And how can you improve your MTTR, your mean time to remediate? This should be how your organization measures how effective you are at patching your open source in your development environments. So MTTR is going to have requirements such as auto OSS updates, like auto PRs, and surfacing OSS vulnerabilities as comments in a pull request. That way you can block the ingestion of open source that's already vulnerable from entering your pipeline. And I'm going to talk about these more in a second. Level 3 then is all about how do you defend yourself against malicious open source. You got to have a deny list. You got to be scanning for malware prior to consumption. And there's also proactive security that you can do to look for those 0 days. How can we all be better members of the open source community by doing proactive security reviews and then confidentially reporting the vulnerabilities that we find back up to the open source maintainers so that fixes can be made and make open source better for everybody. Level 4 is mostly aspirational in nature. It's for mitigating against the most sophisticated adversaries, the type of adversaries that would have the ability to inject themselves into the build process and add a backdoor or compromise the build while it's being built. So because this is mostly aspirational in nature, this should be reserved for your most critical software within your organization. It would be worthwhile for you to do this on a smaller scale to protect your most heavy critical apps. That said, there are tools starting to emerge that are starting to do this at scale, which is making this more and more plausible and less of a aspirational maturity level. So now I'm going to walk you through each of the practice areas and the requirements that are listed within each and where these requirements are within the maturity model. So for ingest it, as you can see on the left, open source maintainers, they have their open source in places like GitLab and GitHub, and they publish their packages up to these package ecosystems. And as a developer, if the software is available in package form, you should be consuming it into package caching tools like Azure Artifacts, JFrog Artifactory. There's loads of others. And the reason why you want to do that is to protect you against those left pad incidents. If left pad gets removed, you're not affected because now you have a local copy in your feed. And that way you can continue to keep on building. In addition, this is just native how CI/CD and DevOps works today. You need your packages stored in a common location so that the entire development team operates with the same set of packages rather than having packages stored on every developer's desktop. And for native languages like C and C++, you should be cloning the source to an internal location if you're serious about BCDR and making sure that you can continue to maintain the code base if that code base was ever removed. So using the package managers trusted by your team and your organization, making sure that you're using things like NuGet.org if that's like the source that your team trusts. You should be using a local copy of the package to protect against left pad incidents. So that's things like the Azure Artifacts or JFrog Artifactory or whatever tool is native to your DevOps environment. And as we get into level 3, then we're looking at denialist capabilities. This is things like protecting you from the malicious open source. If you are able to malware scan your open source prior to consumption and it comes back with a positive result, that should automatically update your deny list that's effective across your entire organization. So the first time you detect malware, you protect everybody else. And you should be cloning the open source to an internal location. Cloning the open source, we're going to talk more about this in following slides because it provides many, many benefits. All right, so why is focusing on ingestion the most important thing to focus on when getting started with implementing this framework? Well, the problem is developers are incredibly creative. They have so many different ways of pulling in open source into their projects. They can pull them direct from those public package registries, like I was talking to you about with the left pad. They can check the package directly into source control. That's often called vendored packaging. They can use commands like curl bash or wget or invoke web request and have these commands running in their YAML pipelines that are pulling in packages into their project. They can use git clone as another way. They can copy and paste code snippets directly into their code base. They can do private forks. They can take all of their packages and bundle a bunch of them together in a zip file and store that into their source repo. And they can also consume them through an artifact store, like the ones that I had already mentioned. And when you look at all of these different ways, and some of you out there might even be able to think of a few other ways that developers pull in open source, like this is a problem, right? What I'm advocating is that we should be using this last one. Everybody should be using an artifact store so that you have a local copy of the package to protect you from left pad incidents. And this is what you now need to help control your development team or your entire organization to move towards this model. Because how are you supposed to control the supply chain if there's no consistency? I need a single point where I can start implementing policy and implementing security controls to make sure that all of the open source that's being consumed is governed. So I want to teach you a little bit about how to recognize an insecure package source file. What is a package source file? That is things like NuGet.config, .npmrc, pip.conf, pom.xml, config.toml. These are the files that live inside repos that say, this is where I want to pull my open source from, that are specific to the different languages, right? NuGet C#, npm is JavaScript, pip is Python, pom.xml is Java for Maven, config.toml is for Rust crates. So I'm going to show you an example NuGet.config file. In this config file, it's actually pointing to 3 different places where it wants to go grab open source from. It says, I want to grab it from NuGet.org. I want to grab it in my local system, and I want to go grab it from some feed, an artifact feed. And I'm going to tell you why this is a insecurely configured file. So grabbing directly from NuGet.org is bad because then you're not actually reaching into your artifact cache. What's interesting is that with all of these different files, NuGet.config, npmrc, pip.conf, all of those, they call into the CLI. And the CLI, for almost all of these languages, they don't have a deterministic way of calling these different feeds to see which one has the package. They call all of them simultaneously, and the first one that responds serves up the package. So it's very possible that if you were searching for if you needed a package in foo service, but NuGet.org responded first, you might be getting the wrong package that has the same name. That's called dependency confusion, and we're going to talk about that in a sec. Calling your packages cached on your local system, well, that's a bad practice because you should be using a central feed that your whole development team has access to, rather than trying to build with packages that aren't available to the rest of your team. And so issue number 1 is that you're pulling direct from NuGet.org without caching the package. Issue number 2, you're pulling from a local machine. And issue number 3, having multiple feeds actually makes you potentially vulnerable to dependency confusion type threats. So here's an example of a good package source file. It's got a single feed, and it points to your artifacts feed or whatever feed it should be pointing to. But you point it to 1. That way, it always calls that feed, and you should have that feed be able to connect to all the other places that you want it to connect to, as shown in the bottom left here. Now, because I'm showing you NuGet, and this is like how we at Microsoft have protected ourselves from dependency confusion, NuGet actually has very specific guidance on this. They actually tried to solve this problem themselves. So for any C# developers out there consuming from NuGet packages, read up on package source mapping and how you can actually make deterministic calls to different feeds in your NuGet.config file. So scanning for vulnerabilities and malware. Level 1 is just looking for the known vulnerabilities. That's what everybody does today. That's your typical SCA tool. Level 2, scanning OSS to determine if it's end of life. And the OpenSSF scorecard does keep track of some open source that has reached end of life. Level 3 is when we start getting into malware scanning, right? And we need to be able to scan for malware prior to consumption, because if it enters into your developer's environment and then you scan for malware, it's already too late. You've already been compromised. The malware often exfiltrates tokens or credentials or environment variables, and then you have to go through a whole incident response of removing that package, rolling creds, changing tokens. But in addition, when you're in level 3, not only should you be scanning for malware, this is also where you can be proactively scanning for the yet-to-be-discovered vulnerabilities in the packages that you depend upon in your organization. And there's a host of tools out there that are all open source that you can use to do those proactive security analysis reviews. So when finishing up here with seeing how Ingest-it and scanning work together, the ING4 requirement says mirror external source to an internal location, and that provides many, many benefits. It allows you to have a local copy for native code scenarios to protect you from the left pad type threats. It gives you increased BCDR for your most critical dependencies. If you needed to take ownership of them, you could. But because you have this local copy, it also enables you to do those proactive security reviews because now you have the code. Now you can run fuzzers, you can run static analysis tools, and whatever else you wanted to look for those back doors. Last, you can also, in the case of extreme circumstances, if you discover a yet-to-be-found vulnerability and you're coordinating with the upstream maintainer, but the upstream maintainer is not reacting as fast as you would like them to for the risk that your organization has, because you have the copy of that code, you could implement a private fix. That is a temporary risk reduction measure, but you could roll out this private fix to fix your organization if you felt that that vulnerability was high enough severity. And that is getting into level 4 maturity. And I want to emphasize that it's a temporary thing that you could do, because you always want to make the fix public, have the open source maintainer make that fix for everybody, and then switch back to that publicly fixed package. So scanning for malware, there is an open source thing today called PackJ. They support scanning malware for PyPy, NPM, and RubyGems, which are the three, in my opinion, just tracking all the news articles. Those are the three packaging ecosystems that are hit the most with OSS's malware. And it can be used in your GitHub runner to audit your pull requests, and it also offers sandboxing to detect install time malicious activities. So inventorying, over here on the left, I've got pictures of GitHub Insights, where their dependency scanning capability shows you like all of your dependencies that are available inside your GitHub organization and all of the licenses that are there. So maintaining this automated inventory is so critical, because if there is ever an incident, now you know who is affected. And you can go reach out to those teams that own those repos and resolve the issue. And make sure you have an incident response plan in place. Coming back to updating and talking to you more about that salt stack incident that I mentioned earlier back in 2020. So on April 29th, that's when SaltStack published a fix to 2 CVEs. So they already went through the proper confidential coordination of privately fixing the vulnerability, and then they announced the CVE at the same time that they made a patch available, right? So they did all the right things. But as soon as they made that vulnerability announcement, attackers were able to look at attackers were able to understand the vulnerability, research it, craft their exploit, go find services that were still using the vulnerable version, and were able to start actually exploiting this in the wild within 3 days. And so it's because of that 3 days needs to be everyone's North Star for being able to patch your open source. And something else that's a trend that I noticed, that when there are major RCE vulnerabilities announced in open source, like Log4j, Spring for Shell, and an earlier one, it was called Omigod. All three of those were, because they were all RCE vulnerabilities, attacks or exploits were automated through the Myriad botnet. So we're no longer against human actors, we're also against automated attacks trying to exploit these RCE vulnerabilities in our systems, creating more and more zombies in our zombie machines in their botnet. So being able to update is incredibly, incredibly important. So automate OSS updates using tools like Dependabot, and displaying OSS vulnerabilities and pull requests is another such way so that you block the introduction of new dependencies that have known vulnerabilities already. You know, our usage of Dependabot inside Microsoft, we've seen PRs accepted within 1 day, and that's our going average. So these things do help, and they help you patch faster. So GitHub Dependabot, as I already just talked about, it helps you maintain good OSS hygiene easier. It removes developer toil of having to do these updates manually, and so it helps move you up that maturity model from level 1 to level 2 by submitting these PRs. And so if you're a team where you feel like it's that simple for you to just update your OSS, you could just accept the PR. OSS vulnerabilities as comments and pull requests. GitHub also has a tool that does this called dependency review, and that helps prevent vulnerabilities being added into your repo. Audit. So this is kind of goes along with making sure that we are double checking that developers are consuming open source in the way that we want them to, so that we can start to control our supply chain. So we have these, audit the developers are consuming through the approved ingestion method, validate the integrity of the open source that you are consuming, and when we get to level 3, this is where you want to start verifying the provenance of all open source components to make the binaries match the purported source code, right? That's what NPM is doing today, and we need to all start preparing ourselves to do that validation, because they're providing the evidence, but we need to do the double checking. And when we get to level 4, this is when we're actually like rebuilding the OSS ourselves. We should be validating the SBOMs of the OSS that we consume into our build. SBOMs are something that's just now starting to roll out across our software industry. I'm predicting that it's going to reach a tipping point where it's just going to be commonplace. It's going to be a new software development practice, and we're all going to be living the SBOM lifestyle in about 3 to 5 years, is my prediction. Enforce. So earlier I started talking about the insecure NuGet.config file. And how did we make sure that developers across Microsoft, the 80,000 plus developers that we have, are all following these guidelines? Well, we actually went and broke their builds if they didn't configure in this way. So let me explain to you how dependency confusion attack is performed. So if you had this NuGet.config file that pointed to 3 different feeds, you might have an internal-only package called foo version 1.3 stored in your local feed. And it's an internal-only package. It's not available on the public internet. But an attacker catches wind that you have this internal-only package, so they notice that that name is available. It's up for grabs in NuGet.org. So I, as the attacker, am going to upload foo, exact same name, but I'm going to rev the version super high so that it looks like it's the latest version. And so with dependency confusion, I might accidentally consume the attacker's external package instead of my intended internal-only package. And it's because of this attack that we went and we broke everybody's builds to make sure if they were configured insecurely. Enforcement is, I would say, the newest addition to our strategy to make sure that in today's day and age of protecting our supply chain, that at Microsoft, that's how we're making sure that we are protecting ourselves. So rebuild on trusted infrastructure. So this is where you've already cloned the repos that you care about, the things that are your most critical dependencies. You've got those things stored somewhere inside, internal into your organization, and you could build it yourself on your own trusted build infrastructure. As you can see with this little prerequisite is outside the scope of this framework to determine what is a trusted build system. That's what things like Salsa is for. Salsa gives you those kinds of requirements. So once you get to this level 4 maturity where you're defending yourself against advanced, sophisticated adversaries that can get a presence on the build system, this is when you want to start thinking about rebuilding the open source yourself and building it in a trusted environment, digitally signing the open source that you build, generating SBOMs for it, and then also digitally signing those SBOMs as well. And then last but not least is the fix and upstream. I already kind of talked about this. This is where in extreme cases where if you discovered a vulnerability and you've reported it, but it's not getting fixed in your comfort zone of time of how quickly you want to fix this vulnerability, and you're worried that a 0-day might come out while you're trying to get this thing fixed, this is when you can start to consider doing a temporary risk reduction measure to do a private fix, deploy it in your organization, and then when it's fixed publicly, you switch back to the public version. This is a level 4 maturity thing. It's actually really difficult because when you do a private fix, do you rev the version number? Do you change the name of the package to be internal private fix? There's all these little things that are actually really difficult to think through that make this a very mature process to enact in your organization. So I'm almost done. I want to talk about the S2C2F SIG within the OpenSSF. Our goals are to create awareness. So I'm really thankful to be here and to be telling all of you about this. And I hope you go tell your friends that would be excited about this and have them tell their friends. Because we want community engagement. We would love to hear your ideas and your feedback and your input as we are tackling these things in our community calls. Because what we do is we assess new OSS threats. There was one published just recently that we're currently assessing that was a threat that was not on our list. And so as attackers continue to evolve and new threat types emerge, we have to think, does our current list of requirements help mitigate this new threat type, or do we need to enact a new requirement? And so we're having those conversations right now, and we would love for all of you as security experts to help participate in this. Adoption. We'd love to see more development teams and more organizations start to adopt S2C2F as part of their practices and start to work through the maturity levels, focusing on getting better at fixing vulnerabilities, then focusing on protecting yourselves from consuming malware. And we also want to drive tooling innovation, right? Some of my requirements, like scan OSS for end of life, I don't think SCA tools today really offer a good solution for that. But we should, right? We do it with commercial software today. When we scan for vulnerabilities, we can know if something's end of life, but we don't really have the equivalent in open source today. And so I think that there's a lot of opportunity here for us to improve as an industry to get better at managing the open source that we consume. And so we're developing reference implementations for each CI/CD platform. So we've got GitHub, we've got GitLab, and we've got example solutions that are native to those two different environments. And we'd love for contributions from others to tell us about how to do this in Travis or Circle CI or Jenkins. We'd love for contributions like that. And we're also working on creating a course on the security knowledge framework, which is part of OpenSSF as well, so that you could take training similar to this to make sure that you're trained and certified on bringing this into your organization. And we're also working on potential for international standardization. So immediately, please go download that guide. Give it a star. Share it with your friends. And within a week, I think you should be assessing where your team or organization is within that maturity model, right? We have a questionnaire. We give you questions to go interview your developers to go figure out where you are. And within a month, start modernizing your OSS governance program by selecting tools and technologies to help you move up the maturity levels. Thank you very much, and I'll look forward to your questions.
No surprise, Microsoft makes great products. Thank you once again.
Yeah.
We are going to try this definitely in our company. My question is, I want to know what are your thoughts on applying this framework or in general the software supply chain security as general on serverless technology where developers just write the source code, very limited amount of open source probably on that. How do you think that the threats have reduced or anything on this framework with the serverless, like Azure Functions, AWS Lambda, whatever? What do you think about?
Oh, so, okay, I want to make sure I understand your question. So we use this framework internally at Microsoft, which is basically how we are building security in. So when you use Azure resources like Azure Functions or whatever, like our products are now more secure as a result. Like you can trust them inherently more. I'm not exactly sure I understood your question.
What is the reduced attack surface or threat problems that people have when people move to serverless, and does this framework still apply to serverless or not?
Oh, okay. This framework specifically applies to not production environments. This framework applies to developer DevOps platforms when they consume these packages into the developer workflow. When they're doing builds, when they're downloading these packages to their desktop, that's where this is all about. Just the DevOps environment, not the, because these are the packages that become your dependencies in the products that you ship to production. Okay. And you don't want to ship something that contains malware.
So probably there's a subset of these tasks that we have to do in serverless.
Yeah. I want to make sure I understand what you say with serverless, because I think you're thinking of production environments and not like the DevOps platform. Like,
yeah, but we have supply chain issues even in production, right? Like
correct. Supply chain is a huge space.
Right.
And this is very focused on, this is what software developers across the world should be doing to make sure that the software that they ship doesn't contain all of this, doesn't contain these backdoors or anything like that.
All right, thank you.
Yes.
Hi, I was wondering how you define end of life for open source packages. In the commercial world, they're often declared. Mm-hmm. In the open source world, I'm wondering how diligent open source contributors are to defining their own end of life. Second question is, how do you deal with end of life when open source contributors are consuming open source from other contributors, in other words, nested OSS?
Yeah, great questions. Okay, so first for the end of life, I show you this log4net example here, the third from the bottom. Log4net was made by Apache, and they just updated their repo to say, this is end of life, we're not updating it anymore, yet CVEs still got published about it. So we didn't have scanning technologies that would tell us that, oh, this isn't going to get patched. And it never did get patched. So, obviously end of life doesn't receive support anymore, and that should be a concern when you're selecting your open source. So I don't think there's a consistent way that developers announce that it's end of life, but they usually take the time to update the front page. You can start to see hints of it where developers are looking for somebody to take the mantle and take their place. And oftentimes when they do that, I've read reports that they have a hard time finding other people willing to be the maintainer. What was your other question? Yeah, so a lot of people refer to that as transitive dependencies. You install one thing and it ends up installing a bunch of other things. So if you are pulling in a end-of-life package as a transitive dependency, and you know it, if you're able to know that that's end of life, you should notify the top-level package owner that they're taking a dependency on something that's no longer being maintained, because it's up to them to update their list of dependencies. Developers are often not empowered to update transitive dependencies, because if they update this first, then they could introduce functional breakages, and that's bad. So developers today always wait for the top-level package maintainer to update their dependencies. Yeah.
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 So,
Oh, timeout?
Yeah, I
okay.
apologize. So
Oh, okay.